Hi everyone, welcome to another session of GCSE Maths. In this tutorial, we're going to look at approximation, and this would be our part number 1. So you're going to look at estimating calculations. Here we got an example. It says estimate the value of 23 times 67. So we need to work out the rough value, not the exact value of these two figures. So what we have to do is we need to rounding to one significant figures. So we discussed the significant figure at the part 1 video. So if you want to refer back, so you can go back and look at my previous video. The way we do is, so you go 23 here. So normally we put a vertical line after the first digit, and we look at the after the first digit. If it's more than 5, sorry, I should say if it's more than 4, then we increase the first digit by 1. So if, for example, if it's 6, then we increase this one to 3 and then make the rest of the numbers as 0. So here we go 3, which is less than 5, and so we're going to keep the same number as it is. So we're going to keep the 2 and then make the rest of the number 0. So we go 20, and then here we go 67, following the rule of significant figures. So this 7, which is more than 5, hence we need to round up this 6 to 7. So we go 70. Now if we multiply 20 times 70, that would be 1400. Yeah, so just multiply 2 times 7, which is 14, and then if you multiply 0 times 0, so we just put 2 zeros. So this is the exact value of 20 times 70, which is 1400. Now to work out the approximate, what we have to do is we need to put this sign. Yeah, so you have to remember you must put this sign, otherwise your answer would be wrong. So 23 times 67, and an approximate answer would be 1400. Okay, moving on to next example. Here we got a fraction 423 minus 98 divided by 16.4. Again, we're going to follow the same rule, which is the significant figure. So we need to rounding to one significant figures. So we go 423. So again, we're going to put a vertical line after the first non-zero digit, and then here we go 2. Here you go 2, which is less than 5, hence we're not going to change this number, first digit. So we're going to keep as it is, and we're going to make the rest of these numbers are zeros. So we'll have 400 minus 98. So we're going to put vertical line here, and then we're going to look at the next digit, which is 8, and this is more than 5, hence we need to round up this 9 to 10. So we'll have 100, and then 16.4. Again, we're going to put a vertical line here. After that, we're going to look at the next digit, which is 6, more than 5. Hence, we're going to round up this 1 to 2. So that'll be 2, and we're going to make the rest of the digit are 0. So we'll have 20. Please bear in mind, in terms of rounding to significant figures, if we go any decimal places, then we're going to ignore. Now if we simplify this, 400 minus 100, that will be 300, and divided by 20. Now we can cancel out this 0 with this 0, and if we divide 30 by 2, that will be 15. So this is the exact answer. However, to work out the approximate value, we'll have to put this sign. So 423 minus 98 divided by 16.4, the approximate value would be 15, which is a rough value. And this is our answer. Now next topic is limits of accuracy. We're going to look at an example. Here it says 140 centimeter measured to the nearest 10 centimeter. So what we have to do is we have to divide this 10 by 2, or we have to make it 2 halves, and then we need to work out the upper limit and lower limit. So the degree of accuracy is nearest 10 centimeter. So we divide 10 by 2, which is 5 centimeter. Now we need to work out the upper limit and lower limit. So to work out the upper limit, what you have to do is we have to add 1/2 with this number. So we go 140 plus 5. So the upper limit would be 145 centimeter, and the lower limit would be 140 minus 5, which would be 135 centimeter. So our answer is 145 and 135. So this is our upper limit and lower limits. Now moving on to next example. It says, what is the smallest value and the largest possible value of 62 kg measured to the nearest kg? Yeah, so keyword is the nearest kg. So the degree of accuracy is to the nearest 1 kg, which is we just interpreting this, the nearest kg to number, which is 1 kg. Again, we're going to follow the same rule as before. So 1 divided by 2, so we need to split into 2 halves. So that will be half kg, 0.5 kg. Now we need to work out the upper limit and lower limit. So the value, which is 62 kg, and we need to add the 1/2, which is 0.5. So 62 plus 0.5 would be 62.5 kg, and lower limit would be 62 minus 0.5, that would be 61.5 kg. So this is our upper limit and lower limit, and this is our answer. Okay, so that's it from me for today. Please feel free to ask any question in the comment box, and please subscribe for next video, and thank you for watching.